This is the third video on graphing rational functions, okay? We're going to do problem 7 here. The function is r of x equals 3x squared minus 2x minus 1 over 2x squared plus 3x minus 2, okay? If you haven't watched the first two videos, I suggest going back and watching those before you do this one, okay? So remember, the first step we want to do is we want to make sure the numerator and denominator are simplified, in this case factored. So you can factor the numerator and the denominator. So the numerator factors is 3x plus 1, x minus 1. The denominator factors is 2x minus 1, x plus 2. Okay. It's important to note that none of these factors cancel out. Okay. In the next set of notes, we'll deal with some functions where the factors might cancel out. That creates what we call a removable discontinuity and not a vertical asymptote. Okay. So that's going to be talked about in the very near future. All right. Once we've factored, okay, that it's going to allow us to find the intercepts. All right. So the x-intercept is going to be when the numerator is 0, okay? So we want to set this factor equal to 0 and solve. That's going to give us one intercept, x-intercept. We want to set this factor equal to 0 and solve. That'll be the second x-intercept, okay? So x equals negative 1/3 would be the x-intercept from this factor, and x equals positive 1 is the x-intercept from that factor, okay? Finding the y-intercept, we want to go back to our original function, okay? All these terms are going to cancel out. So it leaves us with negative 1 over negative 2, which simplifies to positive 1/2, okay? Remember, in a function, you can only have at most one y-intercept, so we shouldn't have any more than just this one, okay? Vertical asymptotes. We want to see what makes the denominator 0. So we're going to set each of these factors equal to 0 and solve. So I'm going to have two vertical asymptotes in this case. That hasn't happened before, but it's going to happen here. So this would be positive 1/2, and this would be negative 2, okay? So I'm going to have a vertical asymptote here at negative 2, and I'm going to have a vertical asymptote here at 1/2. So halfway between 0 and 1 there, just right of the y-axis, okay? Now, horizontal asymptote. The degree of the numerator is 2. The degree of the denominator is also 2. So we're just going to do a ratio of these leading coefficients, so 3/2, okay? So the horizontal asymptote is going to be here at 1.5, or 3 over 2, okay? So because we have two vertical asymptotes, notice my table of values is a little bigger than the one I had in the previous couple problems, okay? So we want to approach negative 2 from both the left and the right side, and then we have to approach 1/2 from both the left and the right side, okay? So I'm going to start with negative 2. So to the left of negative 2, I'm going to go a little further over there, negative 3. When I plug that into my original function here, I get 4.571, approximately, okay? Let's move a little closer to negative 2 from the left. When I plug in negative 2.5, I get 7.583. And then let's get right up next to negative 2, negative 2.1. And you can see we get 31.6 almost, okay? And you can see the pattern here. Y is getting progressively larger. So we're going to say that as x approaches negative 2 from the left, y is going to approach positive infinity. Okay? Now let's approach negative 2 from the right side. So we plug in negative 1, we get negative 4/3, negative 1.333. Okay, let's move a little closer to negative 2. So negative 1.5, we get negative 4.375. And then let's get right up next to negative 2 coming from the right side. So plug in negative 1.9. And you've already seen the pattern, I think, but notice we get progressively greater magnitude in the negative numbers. So we say as x approaches negative 2 from the right, then y approaches negative infinity, okay? All right, second vertical asymptote at 1/2. Okay, so we want to approach 1/2 from the left side. So I'm going to start off with negative 1/2. When I plug that into the function, I get negative 1/4. When I plug in 0, I've already done that here. It's going to be my y-intercept there, so I don't have to do much extra work there. And then let's get right up next to 1/2 coming from the left side, 0.4, and that's going to give me 2.75, okay? So notice this is getting progressively larger, so we say as we approach 1/2 from the left, y is going to approach positive infinity, okay? Now let's approach 1/2 from the right side. Okay, so 1.5 is going to give me 0.393. 1, when I plug that in, I'm going to get 0. Okay, that was from my x-intercepts up here. And 0.6, I'm getting closer and closer to 1/2 from the right side. That's going to give me negative 2.154. So you can see the pattern. We're getting smaller here. So as we approach 1/2 from the right side, y is going to approach negative infinity. Okay? Now the end behavior, okay, because we have two vertical asymptotes, the end behavior, the horizontal asymptote, has nothing to do with this part that's going to be in the middle. Remember, the horizontal asymptote has to do with the extreme left and the extreme right of the graph, okay? So in the middle, again, nothing to do with the horizontal asymptote. We're going to actually intersect that, and that's okay. All right? So let's plug in a really large negative number. That's going to give us 1.503. Okay, so we're approaching that 1.5 from above. Okay, when we plug in a really large positive number, we get 1.497. So we would approach this horizontal asymptote from below. Okay, so the end behavior is going to be this. As x approaches negative infinity, we're going to approach that horizontal asymptote from above. So the left-hand side is going to look something like this. Okay. On the right side, as x approaches positive infinity, we're going to approach 3/2 from below. So the right-hand portion of the graph is going to be this shape right here. Okay. So let's graph using all this information we've just calculated, and let's draw this graph. Okay. So for the graph of this rational function, I've already got my vertical asymptotes plotted here. I've got my horizontal asymptote plotted. So verticals at -2, x equals -2, and x equals 1/2. Horizontal here at y equals 3/2. Okay. So we know a couple points there on the left-hand part. So over here on the graph where we had a couple points. We had -3, 1, 2, 3, up about 4.5. So 1, 2, 3, 4.5. So we've got that point there. Okay. We also had a point like -2.5. So -2.5 up to almost 7.5. So 1, 2, 3, 4, 5, 6, 7.5. So we're right about there. Okay. So we know using the behavior approaching the asymptotes, -2 from the left, we were approaching positive infinity. And then the end behavior here, we were going to approach that value going that way. Okay. 3/2 or 1.5 from above. So that's going to be that piece of the graph. Okay. Here in the middle, remember, the horizontal asymptote can be crossed. Okay. To be a function, we can't have a vertical asymptote be crossed. Okay. So we can cross this horizontal. Don't worry about that. That only has to do with the extreme left and extreme right of the graph. Okay. So now I'm going to post my intercepts. I had an x-intercept at -1/3, and I also had an x-intercept at +1. Okay, I'm going to use that a little later. Okay, my y-intercept was at 1/2. Okay, and then we had some other points in there, so like -1.5, excuse me, and down to -4.375, 1, 2, 3, 4, and a little bit extra. Okay, and then we also had a point here at like 0.4 and then 2.75, so up to 0.75, so we're about right here. Okay, so again, we're not going to cross that vertical asymptote. So using our behavior, as we approach -2 from the right, we were going down to negative infinity. Okay, I'm going to connect these dots. I've got a little curve there. And as we approached 1/2 from the left, I was going to positive infinity. So that's what the middle portion of the graph is going to look like. Okay, and then finally, I've got a third piece here. Okay, we've already got our x-intercept here at +1. Okay, some other points that we plotted, we had 1.5 and then 0.393, so just above that. Okay, we know the behavior. As we approach 1/2 from the right side, we were going down to negative infinity, and we know our end behavior as we approach, as x approaches positive infinity, we're going to approach 1.5 or 3/2 from below. Okay, so that's going to be the graph of the function in number 7.